All right, I think it's time to begin. Good morning, everyone. Welcome to the stream. So today, our March seminar on public transit is part of the York University Student Chapter, the ITE York University Student Chapter seminar series. So a little bit about us before we get started. We are the ITE York University Student Chapter. That's the student chapter of the Institute of Transportation Engineers. We are York University's community of transportation professionals, hosting seminars, software tutorials, fuel trips, volunteering and social events, and better days. Some of these events are member exclusive. Membership is free, so please check out www.it.club.yorku.ca, or if you're a York student, check us out on campus groups to join the club. All right, so without further ado, let's get started with today's seminars and today's presenters. Today we have three speakers, Audrey Ropoyer joining us from Arup, Michael Benetti from Durham region, and Jonathan English from the Toronto Region Board of Trade. This is the first seminar in which I actually know everyone who's presenting from outside of these presentations. I've worked with Michael in a Canadian Urban Transit Association conference and watched Jonathan's presentations. And I also know Audrey from Arup as well. So it's fantastic to have everyone here today. So first up for our presentations, we have Audrey. So Audrey is a senior fire engineer with Arup in Toronto. Prior to joining Arup in 2018, she worked as a research officer at the National Research Council of Canada. She holds a PhD in engineering and has experience evaluating the fire resistance of a lot of construction materials and assemblies, as well as assessing water requirements for firefighting in commercial, institutional, and residential buildings. She's been involved in a number of public transit projects, including the Finch West LRT in Toronto, Station Aéroport of the Réseau Express Métropolitain in Montreal, and most recently, the Eglinton West Crosstown Extension in Toronto. So I'm going to set this up for Audrey. Audrey, the floor is yours.
Thank you, and thanks for the invitation. So I will share my presentation. You can all see it. So I will give a bit of an overview of the Finch West Light Rail Transit project. I'm kind of focused on the scope of the project and the design disciplines that are involved. So I think this has mostly been covered, but just as a little bit of background. So I'm a senior fire engineer. I did my bachelor's in civil engineering at the University of Ottawa, and then my master's at Queen's University, and my PhD at the University of Edinburgh. And I've put some example of the transit projects I've worked on, some of the experience I have. So it's been kind of a range of different types of projects. Finch West, which is the one I'm going to talk about today, is a design, build, finance, maintain project, and Arup is the prime designer in a joint venture. Station Aéroport was specifically working for the airport on design of one station along the line. The Confederation line was the bid design, so that's kind of before the city decides who will actually do the full line design, and currently working on the Eglinton Crosstown West Extension as part of the technical advisory team. So this time we're advising directly Metrolinx on where the project should go. So a little bit about Arup for those who haven't heard of the firm. This is a map of our offices across the world. I think it's as of 2017, so I think it's up to date, but there might be one or two differences. So in Canada, we have two offices, Toronto and a smaller one in Montreal. And as you can see, we're spread out through most of the world. So we're a fairly large global firm. We hire designers, planners, engineers, architects, consultants, technical specialists. We work in just about every part of the built environment. The firm was founded in 1946 by Arup in London. So our headquarters are in London, and I think that's where we're better known. Our mission is to shape a better world. So that involves some values that are kind of focusing on quality of work. So always putting out really good design. Total architecture is something that we push a lot, which is essentially making sure that we consider all the disciplines involved when we're doing a project and making sure that everything coordinates and works together well. We're a humane organization, so that's both for our own staff, but also externally. We do a good amount of community engagement projects and similar, basically pro bono work for different causes. Straight and honorable dealings is something that we're quite serious about. So we won't work with partners if we have concerns that they won't follow that ethic. Social usefulness is something that we think is important. So that's both in our client projects, where we will choose projects that we think will have a positive impact, and also, as I mentioned, kind of the community engagement and similar type of work. And reasonable prosperity at the end. We still want everyone to get paychecks, so something that still comes up. Our Toronto office currently has approximately 300 staff. And our main focus are the transportation and building sectors, but we do a lot of different things. So an overview of the Finch West project for those who are not familiar. This is where it's located. So, this is the line 1 in Toronto for those that are familiar with the city. These are the 2 other LRTs that are kind of currently planned or in construction in the city. So it will connect to the Finch West station on line 1, which is just one stop south of York University. So most students have probably seen it or passed by it. And this is what the scope of the line will look like. So it will have a station at Finch West, a stop at Humber College, which is more like a station, and then add grade stops along the line, along the avenue, and a maintenance and storage facility near North Finch and Oakdale. So it's an 11-kilometer line. It's running through a fairly low-income area that currently doesn't have any other rapid transit available. So it should serve kind of the purpose of the social usefulness that I was talking about. This is an important project for the area. It will be primarily street running with the 2 stations at each end. And it's running in the center of the roadway in a dedicated line, so it will only cross traffic at intersections. So there's one station at Keele and Finch West Station, which will be an underground terminal station, and it will connect to the TTC station, 16 at-grade stops, and 1 open trench terminal station at Humber College. So it's sort of below grade, but open to the atmosphere. 1 maintenance and storage facility, as I mentioned, 9 traction power substations along the line total. Most of the line will have embedded track. There will be tail tracks at the end of the 2 terminal stations. And the light rail transit vehicles will be powered by an overhead catenary system. And one of the kind of bigger ticket items that came along with this project is the replacement of the Overpass bridge at Finch and Highway 400. Kind of, it needs to be replaced for the project, but also it was near its end of life, I believe. So that was kind of tacked on to the project. So here are some pictures. These are from the Metrolinx website, so I'm not taking any credit for these, but essentially the progress of the construction. So early works to kind of relocate some of the utilities started in December 2016. Actual construction started in earnest in 2019 on the maintenance and storage facility and the bridge replacement. What you see here is the hole for the Finch West station. This is some of the work along the center line to change the alignment of the road. And this is the maintenance and storage facility that is almost completely constructed at this point. The estimated travel time for the whole line will be 38 minutes, and trains will run every 5 to 7 minutes during peak hours. It's not the highest ridership level or the most crowded, but it will provide transit in an area that's underserved. And the project will cost approximately $2.5 billion. Just a few overviews of the key pieces, I guess, of the project. So there's the Finch West station, which is an underground terminal station. This is a rendering of the main entrance to the station, and it will be connected via an underground tunnel to the TTC station. The maintenance and storage facility, this is a rendering again, but it will have this very large train storage and maintenance area in which the trains will drive and will be able to be cleaned and etc. It's a fairly large facility, and it will have administrative offices, inspection facilities, and there will be a electrical substation on site as well. And then the Humber College stop, like I said, this is basically kind of below grade but open. So you'll go into these two entrances and go down to track level. This is near Humber College, so it's going to be connected with existing campus facilities, and it's also integrated with the local bus and transit services in the area. So that's basically an overview of what the project is. And what I wanted to kind of talk about a little bit is how complicated this project is and what needs to happen to make this design, make this project a reality. So it's truly multidisciplinary project, and I think sometimes when people hear train or transit, they think about roads and they think about train systems, but there's so much more to it. So here's a partial list of some of the Arup disciplines that are involved in the project. There's more slides. So architecture was involved. They designed the stations, the stop, the maintenance and storage facility, the traction power substations. Then there was structural engineering. So they designed the structure of buildings and the stops, but also of the overpass bridges and those structures. Mechanical engineering was involved to do heating, cooling, and ventilation, plumbing and drainage, and fire protection systems of the buildings. And similarly, the electrical engineering discipline was involved for power distribution, lighting, fire and alarm systems, emergency management panels in the stations, stops, maintenance storage facility. Then you have civil engineering that's heavily involved in looking at site drainage and grading, water distribution, stormwater management. There's a culvert replacement project. Geotechnical engineering is involved for the tunneling at the Finch West Station, the open cuts and all the foundations and footings for the buildings and for the track, the portals and the retaining walls along the whole alignment. We have building information modeling, which is supporting all the design of the buildings and just collecting all the information that we need so that this complex design all comes together. Transportation engineering is obviously involved to figure out the new road alignment, the structure, traffic signals. I'm part of the fire engineering discipline, so we looked at safety in the stations, in the tunnels, along the guideway, making sure that people can evacuate safely. Tunnel ventilation engineering is kind of a specialist discipline for the Finch West Station in particular. because when you have a completely underground tunnel, you can have, if you have heat rejected from the trains or the systems underground, it will accumulate and it could get too hot, so you need normal ventilation. But also if there were a fire, smoke would accumulate in the area, so you need emergency ventilation. Transport planning was involved. I put pedestrian flow analysis, but there's more to it than that. Some of it was done in collaboration with Metrolinx, but it's basically about figuring out the capacity of the stations, how many fare gates do we need so people can go through at peak times, will the stairs be too crowded? And then we look at things like intermodal connections, so the bus stops and transport from one to the other. Rail operation is obviously an important discipline, so what should the schedule of the trains be? What are the travel times and the speeds along the line? Where do you need to slow down and speed up to accommodate the alignment? And then some of the specialties that were brought in for kind of, point things, accessibility and inclusion. So we have specialists that help us understand the requirements to make sure that all the stations and the stops are accessible to people with various disabilities. Safety management, reliability, availability, and maintainability is actually a pretty important discipline in rail design, and it's essentially about making sure that we meet the targets of the contract in terms of the system being performing to the level that is expected, so the trains will come in on time and people will be able to board them as frequently as they want, etc. Seismic engineering always comes into all these types of projects when there's buildings. Wayfinding is important in stations and stops. We want to make sure that people will know where to go to get to their destination, but also how they can connect to other services. And then interface design is something that I can't explain because it's very complicated, but super important because basically all of these things I just listed need to come together in some way. So we have experts that make sure that happens. And then there's other disciplines that Arup doesn't necessarily offer that were involved in the project. So we had sub-consultants who were helping with things like landscaping, traction power engineering, the design of the overhead catenary system and the signaling systems, and the drain control, and the communications and networking, track design, environmental engineering, street current design, street lighting, telecommunications, and I'm sure I'm missing a bunch of them, by the way. So essentially the message that I'm trying, after listing all of these, the message that I'm trying to convey is that this is a truly interdisciplinary project. Is very large and you need everyone on board. So whatever discipline you're in or whatever your interest is, there's always kind of sub-disciplines and specialties that are needed. So you probably can be involved in these projects if you're interested. That's basically what I wanted to talk about.
Awesome. Thank you very much, Audrey. So I think we have about 5 minutes for any questions from the audience, specifically for Audrey. We also will open it up for questions for everyone later on today. Any questions? So, okay, hearing none at the moment, but I've got one specifically sort of on fire and also regarding general design. So Humber station is going to be an open air station. So it's still in a trench, but it's open to the environment. Is there any reason why that was chosen over, say, a complete tunneled design? And also, what's the fire implications for that, or the fire safety implications?
Somebody's been doing some reading, I think. That is part of the reason. So there's, the construction of an open trench station is less difficult and less demanding than a tunnel for, sort of obvious reasons in terms of the amount of infrastructure that's required. But in terms of fire safety, it does help. So we considered the section of the track that is open to the atmosphere to be an open station, to be open air. it will vent if there is a fire directly to the atmosphere. So we don't need to worry as much about emergency ventilation and mechanical ventilation system as we would in a tunnel. The main thing we need to worry about is the connection with the two entrances, because those are enclosed for just thermal comfort and practicality of being in a city like Toronto. So we need to make sure that if there is a train fire or any other fire on the platform, that smoke can't come through the stairs up into the two entrances. So we've basically got mostly passive systems like glass panes that are blocking the way around the stairs so that smoke can't rise up. But yeah, it reduces the amount of design and the amount of maintenance and cost that goes along with the mechanical ventilation systems, because those are quite involved.
Awesome, thank you very much. Part of the reason why I'm also asking that question is I'm here in Ottawa, where our LRT, a lot of our stations are of the open design type, and it always makes me wonder, so what if you were to completely enclose these stations, what would the considerations be? So thank you very much. Tanvir, you can go for one question for now. I know you always have lots.
Thank you so much, team, and thank you, Audrey, for the nice presentation. I believe it was really great for all of us to know about this project. I have a quick question. That one is on the alignment design. What are the difficulties you guys have faced when you do the alignment design for this corridor? Like how, and also my another question is how it's integrated with the Finch West station.
Okay, so in terms of integration with Finch West Station, both stations are underground, essentially one on top of each other, and there will be an underground tunnel that connects the two stations. They're at different elevations, so that was kind of a challenging design, and there's a lot of stairs. Fair warning to anyone who's planning to transfer from one to the other. There's also a ramp for accessibility, but it's the fairly steep tunnel. But yeah, so they're connected underground and they're essentially on the same site. They have separate entrances, but you can go through from one to the other. In terms of the alignment design, I am not an expert. I didn't do a lot of work in that area, and a lot of the alignment was already decided by Metrolinx by the time we got involved in the project. But one thing I would say is that it's always challenging when you're trying to essentially add two train tracks in the middle of a road without expropriating everyone who lives on both sides of the avenue. So there were sometimes compromises that had to be made. And some of my colleagues could probably give you more of an answer on that specific questions of what some of the other challenges are. I don't know that many specifically, but there were instances where normally, for instance, the catenary system would have had poles running in the middle of the two tracks, and we had to come up with some clever solutions because it wasn't wide enough anymore. For safety reasons, we always want to have some kind of maintenance and evacuation corridor, either on one side or both sides of the tracks, depending on the design. And sometimes that's challenging because we can't have obstructions, but then the electrical people want, some kind of electrical distribution system, and the mechanical designers need to put a standpipe for fire protection in there. So there's a lot of equipment that does need to go along the tracks, along the alignment, besides just the tracks themselves, and fitting it all in can be a challenge.
Thank you so much.
Awesome.
Team, am I allowed to go for one more question?
No, I have one more question that's come up in chat, but we can definitely circle back around to Audrey at the end, okay?
Sure.
So I have one more question before we move to our next presenter, and this one has come up in chat. So does your entrance and exit design requirements change with open stations versus an underground station? Or is there like a preset criterion or guideline that's used?
Entrance and exit requirements in terms of the train?
I think this is for the stations, so like station entrances or exits.
Oh, right. So I mean, the at-grade entrances are, you've seen them elsewhere in the city. They're literally glorified bus stops, right? They're kind of like elevated sidewalk with an overhead, protection, some benches, and that's pretty much it. So there's essentially no structure there. For the two stations that we have, there's differences in the design between Finch West and Humber College, but it's mainly due to the complexity of it. So the Finch West station has more rooms in it. There's more electrical, mechanical support and stuff. So it's a larger station. And some of that has to do with the fact that it's underground, so to support that design. Some of it is also just because practically that's where those things were located. There's requirements in the building code about what needs to go at terminal stations. So for instance, you need to have washrooms in terminal stations. I don't know if anyone's ever noticed that most train stations won't have washrooms in them, but the terminal facilities do, like public washrooms. So I would say the main difference is that because there are more systems to support the underground station, you need more rooms for those, and that also implies more staff working in the area. So it tends to also imply more support rooms like meeting rooms and private washrooms for the employees and things like that. So that's kind of the main difference, I would say. There's specific requirements in terms of construction when it's above ground or below ground. That's kind of
Awesome. Thank you once again, Audrey.
my pleasure.
So quick round of applause for Audrey. And I'm going to steal the screen share back for our next presenter. So coming up next, we have Michael Benetti. And Michael is a transit planner with experience working both in Canada and the United States. He currently works in Ontario, Canada, where he plans transit services in both urban and rural settings. To date, he has worked on bus network redesigns, adapting transit services to the challenges of a pandemic, implementing on-demand service, and the formation and implementation of a 5-year and rural transit service strategy. So from all over, here is Michael. The floor is yours. Welcome.
Thanks, Timothy. So today we're going to go over actually a project that I did right when I started my career about 8 years ago back in Cleveland, Ohio. And it's still one of my favorite projects, and it's a great way to enhance public transit service when you maybe have limited funds and not as much vehicle availability and funding to say build a frequent transit system. So today we're going to talk about building a pulse, and what I mean by that is a transit schedule pulse, either for rail or buses. And so we'll get started here. So when you're planning transit services, there's sometimes challenges. You may have low frequency transit routes in your network. As much as we like to get service very frequent, sometimes demand just doesn't warrant frequent service. And so, there's not the impetus to put in, 10-minute service. There's budget constraints. You may not be able to put in frequent service because of that. And because of this, transit riders often miss connections, and the transit system is not as attractive to riders, especially if they have a choice. So there is a solution that we can do with our scheduling to make transit service more attractive and nimble when we can't provide that frequency. And in Europe, it's often called the TACT because it's related to services in Switzerland and Germany. But in North America, we often call it a pulse, and it's just a pulse network of scheduling. So it's a pretty simple concept. How it works is you just ensure that you schedule your services to connect, for example, at major stations. And so in this example here from Switzerland, buses come in 5 minutes before the trains arrive and depart. The trains arrive and depart, and then the buses leave 5 minutes after. And this is a pretty simple one, but Switzerland likes to do it quite complex. So the Swiss rail network actually has a TAC system or pulse system on their entire national rail system. And what's great about Switzerland is it's not just the rail system. When you're on the rail, you'll get off at a station, and then the local buses at that station are also on a tact or pulse system. And so basically you just need to know the schedule for your first bus. And because they're all on these pulse schedules, you really just need to know what time they depart each hour from the stop near your house. And once you're on the network, you basically don't have to worry about a schedule traveling throughout Switzerland. When you get to the next train station by bus, those trains will automatically be connecting to other trains to other cities. When you get to the next city, those trains connect with buses. And so the Swiss really take it to the nth degree almost, where we don't really have anything in North America this complex, but it is an example of how you can do a national pulse system if you wanted. And the Swiss implemented this when ridership was declining post-World War II. Just like here, people were buying cars and they didn't want to use the rail system anymore. It was inconvenient. And so they implemented this as a simple way to hopefully build ridership. And it's worked so great that they've gone from a 60-minute tack to they're going down to 15 minutes now on major corridors. So it went from 60 to 30 and now 15 because the ridership has just skyrocketed. All from this simple idea that you just run the same schedule 7 days a week so that you know when the trains and buses are coming and you ensure everything connects. So it's a simple concept, but it actually does take a lot of engineering, and a lot of engineers work on projects like this because it's complex with vehicles when they arrive at different stations and all that fun stuff. So does anyone know what North American city introduced a pulse network or time transfer network back in the 60s? Timothy, do you know? Nope. Okay, it's actually in Canada, so Edmonton, Alberta. So Edmonton kind of has like a mini version of this Swiss network in their city limits. And Edmonton, again, after the war, was experiencing the same thing. Ridership was declining. How are they going to stop it? They can't run all the buses every 10 minutes. And so they implemented a timed transfer network. So if you go in Edmonton, the buses all meet at transit centers in each neighborhood and connect with other buses that then take you downtown or to the university. And they're actually getting away from this because the city has grown too large now to support this sort of pulse network anymore. They have to move to more frequent service. But it was a model back in the 60s for North America. So that brings us to Cleveland, Ohio. So we're going to fly across Lake Erie, about just southwest of London, Ontario, to Cleveland. And that's where I implemented the Windermere Pulse. And it's been operating for about 8 years now, or just over 8 years. And this was really about building connections in the eastern suburbs of Cuyahoga County. And so you may be asking what that looks like. So here's Cleveland, or Greater Cleveland. Downtown is in the center there. They have University Circle just east of downtown, which is like a midtown area, university district. And then about 5 minutes east of there, you have Windermere, which is a major suburban subway station. So think of it as Cleveland's version of Kennedy Station in Toronto. It's in the East End. It's a lot of buses feed into it. And it's one of the busiest hubs in Cleveland. It has 12,000 boardings and alightings on buses a day there, not including the rail system. And these are the routes that feed into Windermere. And so the problem with Windermere was low frequency transit routes. Some were running every 40 minutes, every 60 minutes, and they weren't timed to connect. So when I started this project, we had some buses coming in at 28 after the hour, and the other bus had just departed at 27 minutes past the hour, or 25. And so a customer would come in, and you would have almost an hour wait for the next bus, or a 40-minute wait because they weren't connecting. So transit riders were missing connections, and transit riders in some cases had to travel further to make connections. So an example of this is if you were traveling from Lakeshore Boulevard up in Euclid near the lake there, and you want to go to Southgate Transit Center, there is a route that takes you directly to Windermere. And then at Windermere, there's another route that goes directly south to Southgate. However, if you typed this into Google prior to the Windermere Pulse implementation, you would be directed to take a bus downtown and then a bus out of downtown to Southgate. So what should really be a 30-minute ride, you'd be traveling 30 minutes into downtown and then 30 minutes out again, because there was an hour transfer wait if you went to Windermere. So this was the problem that was going on there. And so what the Windermere Pulse did is we implemented consistent schedules, which then improved connections. So the first thing we had to take into account was the schedules. We had to transition to clock-based schedules. So pulses work really well if you go on a clock base. So no 40-minute schedules that you can't remember because it changes every hour. You got to move to like a hourly, 30-minute, 15-minute, 20-minute schedule, anything that divides in evenly with that. Because of that, some services became more or less frequent. So we had to look at the impact on capacity. So one bus route, we had to go from a bus every 16 minutes to a bus every 15 to fit that that pulse clock face schedule. Another bus had to go from every 25 minutes at rush hour to every 30. And that doesn't sound like a big change, and it's not, but we still had to do capacity checks because that going from 25 to 30 meant, I think it was every third hour we lost the trip. So we did that. We saw it would work properly and that the capacity was sufficient. So we implemented those changes. Some services got better. There were services, like I said, that were running every 40 minutes. They either went to half hourly, and in some cases went hourly. But again, we checked the capacity on that. We had to look at the bus terminal. We were dealing with a bus terminal that didn't have a lot of capacity. So can all these buses come in at the same time and be serviced? And the result of that was that one or two of the bus routes could not come in at the same time. We had to schedule it in between, as you'll see. And we want to ensure sufficient transfer time. So you have to think about customers with disabilities that have to maybe use elevators or are not as fast to walk between connecting buses or coming from the train. So we did walk distance tests to see how long it would take to get from a bus to the train and all that, so that we knew the sufficient time required. So we came up with a transfer window of 10 minutes from when a bus arrives to when the next bus departs. And we also have to take into account bus cycle times, how many vehicles we have available. And in this case, because we had to add a vehicle on one of the routes, we were able to extend the service further than it was operating. So that was a benefit out of this Windermere Pulse. And so this is what it looked like. So the main changes happened on two routes, the Route 30 and the Route 41. So just to give you an idea what happened, the Route 30 went from every 16 minutes at rush hour to 15, and went from every 40 minutes off peak to every 30 minutes or every hour. The 41 ran every 40 or 45 minutes on its entire route. And what we did was we split it up. We did short-term trips. So we ran 30-minute service on the busiest portion of it to a place called Southgate Mall. And then south of Southgate Mall, we ran it every hour or every 30 minutes, depending on the time of day. And the other routes basically stayed the same. They were already on a clock face schedule of every half hour, hour. And so this is what the pulse cycle looks like if you go to Windermere today. So buses, we have, there's more than one pulse. The main pulse when services are running hourly is at the 40 and 50 mark. So if there's service every half hour, every 15, it just follows the pulse in order. So what would happen is buses arrive at 40 past the hour, and the rapid transit train also arrives around that time. You have about a 5-minute wait, and at 45 past the hour, there's a bus route that is not able to come in and sit. It's a through route, so that bus comes in about 45 past the hour. So customers from the other bus routes can transfer onto that route, and customers on that route can also get off at Windermere and transfer onto any other bus route there. There's then about another 5-minute wait, and at 50 past the hour, most bus routes depart. And then 2 minutes later, the rapid transit train departs westbound towards downtown. And so there's basically seamless connections between every route at Windermere. You know, once you get on that first bus, when you get to Windermere, you don't have to worry about your connection. And so this is what it looks like today. So you can see the buses here on the Route 28, they all arrive at 11:41 past the hour, except the Owl service late at night there. And they all mostly depart at 21:51. And you can see the same thing on the Route 30 there. And this is the Route 28 during weekday service. And you can see the base service does arrive at 11:41 past the hour, except that weird anomaly at 7:10 there. And then if you're adding in service because demand is higher, you slot in the service in between. So the service is slotted 15 minutes in between that, so that customers know you have the base trips and then the additional trips are slotted in. You never have to worry about the schedule changing. And so what were the benefits? Well, there's easy to remember schedules. You know when they arrive and depart Windermere. Lengthy transfers were eliminated. There's a reduced walking distance for customers. They didn't have to walk further to another bus route that had a more direct connection, they could go to the stop closest to their home. And obviously reduce number of transfers, no more having to travel downtown to come right back east again. And so this opened up new travel opportunities in an area of Cleveland that is one of the poorest areas in America. Customers are traveling 2 hours. I interacted with some customers traveling 2 hours to get to a $6 an hour job, for example. And so this is a great benefit to them, allowing access to jobs and reducing their travel times. And we also were able to enhance transit service. So we were able to provide more opportunities to travel on the, for example, Lakeshore corridor there. And the last bit, we were also able to handle the crowding at Windermere and make it a little bit more orderly. So we have Windermere, but that's not all. What else could you do? So we didn't have the funding to do a Windermere version on the west side, but there is a station on the west side called West Park. And that's sort of like the Windermere of the West. And because the funding wasn't there, we couldn't do a full pulse. But what we were able to do was coordinate the service so that some routes connect. So it is possible to travel on a route to Windermere. You get on the rapid transit train. That specific train is scheduled to arrive at West Park. And then where we were able to, there are select bus routes that you are then able to transfer onto to travel to other destinations. So some of those bus routes run hourly, and so we were able to coordinate that a little bit so that you don't have an hour wait when you get to West Park, and the same thing in the other direction. Those buses will get you to West Park, and that rapid transit train will connect with the Windermere Pulse. So, there's different ways you can do this. If you don't have the funding or vehicles available to do a full pulse, you can also do these sort of half pulses that help out residents a little bit, at least. And so I'm just going to close with a quote from Paul Mees, who was an amazing transit planner. And I'm sure, as Jonathan will get into, sometimes planners and engineers can sort of sabotage public transit on their own. We use excuses on why public transit is not good and is not carrying people. But we have to remember that we have to stop telling ourselves that it's an impossible task. You can do things like the Windermere Pulse to improve transit and make it a viable option for residents.
Awesome. Thank you very much, Michael. Do we have any questions for Michael? I'm going to kick it off with one of my own questions. So the idea with the pulse, of course, is everything comes together at the same time. What happens if a bus were to be delayed outside of the pulse window that's allowed? Do the other buses also wait?
Oh, that's a good question. So it depends on the transit agency. So in the Greater Toronto area, there's a lot of pulses at the GO train stations. So if you arrive, say, Oakville Station, and the trains are like 10 minutes late, sometimes those transit agencies do hold the buses. In this case, we built in the 10-minute window because 10 minutes is a little bit long for a transfer, but we're not the Swiss. So the Swiss time them like 5 minutes, and some of them are timed with a 1 or 2 minute window. For accessibility, that's not the best either. So we did a 10-minute window, and that captures also if a bus is late, generally they're within, a 5 or 10, 5 minutes late or something. So that also takes into account if there was a one-off where a trip is late. Beyond that, in this case, at Windermere, no, they would not hold a bus. It's just you'd have to wait for the next pulse. But because of that large transfer window, we didn't really have any problems with late buses and missed connections.
Awesome, thank you. Questions from anybody else? Okay, hearing none. Well, we also have time at the end as well. So thank you very much. Thank you very much, Michael.
Thanks, Timothy.
All right. And coming up next and last for today's presentations, we have Jonathan English. So Jonathan is the Director of Policy for Transportation and Infrastructure at the Toronto Region Board of Trade. He's written on transportation and other issues for publications including the Globe and Mail and Bloomberg City Lab. He has a doctorate in urban planning from Columbia University with research examining suburban transit policy and the relationship between transit service levels and transit demand from a historic perspective. His research has also been featured in outlets including the New York Times, Vox, Wired, CBC, and NPR. So welcome, Jonathan.
Hi there, it's great to be here. I will share my screen. So it's great to be speaking after Mike. Mike's a bit of a transit planning. I know Mike, but he's also a bit of a transit planning hero of mine in that, not only is he really creative about how to do more with the resources that you have, but he's also somebody that you saw with his quote from the Australian scholar Paul Mees at the end. He's somebody who very much looks at the scholarship, looks at the academic literature around this stuff on his own time, and he takes what he learns from that academic literature a lot and really applies it in the real world as a transit planner. So that's exactly what you want to see. Because there's lots of great research like Paul Mees going on in this area around the world. So I called this presentation The Chicken and the Egg. It's about building transit ridership in suburbia. So I'm actually mostly going to look at the Toronto area because it's, I think, pretty familiar to all of us. I know it's Zoom University right now, but I imagine most people have at least spent some time in the Toronto area. So one of the things that I'll start with is, I'm going to talk about the relationship between service and transit demand, because this is something that is often maybe confused is a bit of the right word, but the causality really, what I will argue, goes both ways, and that's something that's not always completely recognized. So actually, I developed this list with Mike and another transit planner. But I'm just borrowing that right now just to give a very brief overview of what I mean by service, because I'm going to be talking about that a lot. So it has a number of different elements: coverage, how much of the region does the network serve, frequency, how often do the services come, the bus or train, span, how much of the day does it operate on weekends, into the evening, speed, how long does it take to get somewhere. Fair fares. So is the fare structure reasonable? Is it roughly based on how far you're actually traveling, or are there very different fares based on whether you have to transfer? Do you have to pay more for that? Do you have to pay more if you switch between agencies? Do you have to pay more if you switch between bus and train? That's something that kind of lessens the quality of service for riders. Accessibility, is it accessible to everyone, regardless of their individual characteristics? Approachability, is it easy to understand, even if you've never ridden it before? And connectivity, is it easy to switch from bus to bus, bus to train, whatever, agency to agency? So, obviously just going over that very quickly, but that's to give you an idea of what I mean by service. So, I'm going to go back into the past a little bit. So I'm going to look at the Toronto region, and I'm not just talking about Toronto because we're in Toronto, but because Toronto is unique. Toronto is the only city in all of North America to increase transit ridership between 1945, basically the end of the Second World War, and 1970. So that's a big, long period. 25 years, quarter of a century, that not a single transit agency in North America increased ridership other than the TTC in Toronto. So, why is that? I think that's worth trying to understand. And what I found when I dug into this in my doctoral research was that when you look at the timing, what it was about was an improvement. It wasn't about building subway. It wasn't, it helped. It wasn't about spending a whole pile of money on infrastructure. It was about improving that basic service that goes up and down your average street so that it came often. And it was about adding service as soon as new neighborhoods were built. That's something that we didn't see in, for example, most of the US. I did my doctorate in the US. I lived there for a long time. And, to this day, I lived in New York. In New York City, sure, you can take the subway most places, but the neighborhoods those subways were built 100 years ago. The areas that were built since the Second World War, Many of them have little or no transit at all to this day. And that's New York City. We're not talking about Phoenix or Houston. So there's no surprise that there's no transit demand when there is no service for that demand to manifest itself. We often think about transit planning the way that we think about highway planning. You build a highway and then drivers can come and drive on that highway. It's fairly simple. And if there's more demand for travel on that highway, if the highway is empty at a certain time, then there's no demand, quite obviously. It's a little bit different with transit because transit is not constantly available. Highway, you could drive it at 2 a.m. if you wanted to, or 1 p.m., whenever. Transit doesn't work that way. If there isn't a trip of your bus leaving at the specific time that you want to go, you're not going to ride it. It doesn't matter if there's a bus at 9 a.m. If you're trying to catch it at 1 p.m. and there's no bus, you're not going to ride it. So that's one of the key issues that we see in the United States, and that was a little bit different in Toronto in that period. And I'll go into that in a little bit greater detail. Again, not surprising, when we compare Toronto with the rest of North America, you can see that in the 1950s, Toronto followed a very similar path of steep decline as everyone was buying cars, everyone was moving out to that suburban house with a garage. But Toronto was able to turn it around in the 60s and then especially in the 70s, while in the US, the steady decline continued. So, if we jump forward, you can see from 52 to 62, Toronto was pretty similar, down about 38%. Chicago 39, Washington 40, Philly 41. Basically, we were more or less the same with similar cities in the U.S. Those cities are a little bit bigger than us in those days. Now they're pretty similar. And you can see what's the upshot of all this. In the end, we've ended up in a situation where Toronto has the second highest, along with Montreal, transit riders per capita in North America. But this is kind of an unfair comparison because most of the TTC service area is post-war suburbia with single-family houses, garages on the house, driveways, winding streets, all that stuff. Most of the New York City Transit Authority service area is tenements, walk-ups, apartment buildings. It's much denser. So if you want, and the same is true of Chicago and San Francisco. So if you want to compare Toronto to another transit agency, you really should be comparing it more to Dallas, Houston, Pittsburgh, Los Angeles to some extent. So, you can see Toronto's in a completely different league from agencies that have to serve large suburban areas. So what happened? In 1953, the provincial government kind of forced on us the municipality of Metropolitan Toronto. And that was a very good decision, I think we can fairly say, by the provincial government. They joined together all of these municipalities. Later, some of the smaller ones were merged together with the bigger ones, but into a metropolitan federation. So they still had their local city governments, but or borough governments, but for big picture stuff, including transit, the decisions were made at the metro level. So what that meant was that the service area of the TTC increased overnight from 35 to 240 square miles, much of which was brand new suburbia or even farmland. But the legislation at the time said that it still had to be financially self-sustaining. So to go back to that time, you have to realize that transit was often private, and in all cases was expected to operate as a business. Toronto, it was publicly owned, but it was expected to turn a profit or at least break even. And that was a mentality that took a long time to change. People thought about the transit authority, especially the private transit authority, as kind of the way you think of your, internet service provider today. They were not very popular. They were sort of an unpopular utility. And the idea that the government should subsidize this utility was crazy. Obviously, if they weren't making money, they were mismanaging their business. So for a long time, this mentality stuck. And what we ended up with was a vicious cycle of as more people bought cars, fewer people were riding the trains. So revenue dropped, but the cost of operating everything stayed the same. So they began to cut service and raise fares. The problem is that drove more people to go buy a car, which caused those two things to get worse again. And eventually you ended up in a situation looking at Cleveland, which Mike was talking about. Transit ridership in Cleveland was around 450, or around just about 500 million a year in 1946, more than TTC today. By 1970, it was at under 70 million. So an absolutely gigantic plunge in ridership because of this kind of vicious cycle of service cuts, fare increases, and ridership declines. So, why did it happen? Why was Toronto different? And I really enjoy this quotation, so I'm going to read the whole thing. It's the experience of every large city in America that a succession of new expressways is not the answer to efficient and economical movement of traffic. Each successive one is filled the day it is opened. The irresistible fact is that you simply cannot provide sufficient highways and parking space to accommodate every person who desires to drive his motor vehicle downtown and back each day. Additional rapid transit is the only answer. The driver cannot be derricked out of his car. He has to be persuaded to take transit by a more convenient and more economical mode of travel with rapid and regular service. Now, that doesn't sound particularly revolutionary today. People say stuff like that all the time. But in 1956, the year that the United States Congress passed the Interstate Highway Act, that was an incredibly revolutionary statement. Maybe Lewis Mumford or, urbanist writers might have said something like that. But here in Toronto, it was actually Fred Gardner, Big Daddy, they would call him at the time, the person that they named the Gardner Expressway after. It was him that said it, which is quite striking because he was a sort of very traditional suburban politician from Forest Hill. But he and a few others in Toronto, but he was certainly the most influential, decided that, that it wasn't working. And he realized this about 10 years earlier than people like him in the United States did. And that 10 years made a huge difference. That 10 years was the period that Cleveland dropped from 500 million to, they were probably down to about 300 million by that point, but say from 300 million to 70. And we stopped at that equivalent of 300 million level and then started to turn it around. So, what are the details of that change? Well, you can see the turnaround occurred in 62 and 63. The chart shows it plain as day. Ridership was dropping and dropping and dropping every year until suddenly it was rising and rising and rising. Just about every year there was a strike here. Now, the key event in those years, we opened the subway in 1954. That didn't really seem to do, on Yonge Street. That really certainly didn't seem to do all that much for ridership. I mean, it did help on Yonge Street, but everywhere else, the ridership continued to decline. What happened in 63 that caused this really abrupt turnaround? It was the expansion of the TTC's bus service, the basic local bus service that runs past every street. They created a grid of routes along all the old concession roads. You know them now well, especially if you're at York, Finch, Shepherd, Steeles, not Steeles yet, Lawrence, Wilson, all of these streets that now have some of the busiest bus routes in North America. Those routes were first created in that 1963 expansion. And nobody expected it would be successful, but it was wildly successful, far, far more than they thought it would be. It was a political choice to provide this service to pacify the suburban councillors who were demanding, the members of the Metro Council. They said, we don't want to keep paying for transit if you don't give us service. And all the experts said, oh, this is a ridiculous idea. Nobody's going to take a bus on this street. It's running past suburban houses. They all have a car in the driveway. Why would they ever take a bus? And yet the ridership exploded as soon as that service was provided. You can see it plain as day on that chart. Ridership actually continued to decline in the old city, through all of this, but it was more than made up for by the explosion of ridership in these new neighborhoods. So even if people had a garage, even if they had a car in the driveway, they chose to use transit, maybe not for all of their trips, but for many of their trips, because they were given that option. And Toronto was basically the only city in North America that was giving its residents that option. And guess what? By the late 1970s, the TTC also had the lowest subsidy of any transit agency in North America, because it had enough riders to generate a reasonable revenue to pay for the service. So you might say, oh, maybe Toronto was special. Maybe our development was different. Maybe we were denser. Well, you can compare Don Mills, which is the quintessential Toronto suburb of the 1950s, with Levittown, which is the quintessential American post-war suburb. Now, if I didn't label these two, I would be very impressed if you could pick out which one was which. I know I couldn't. So maybe it was that we built more subway. I mean, we did open the subway in 1954. But, between 1964 and 74, San Francisco, in only 10 years, built 115 kilometers of rapid transit, the BART system that's still there today. Between 1964, when they started, and 2001, almost 30 years more, Toronto built only 30 kilometers, so 115 to 30 in twice the time. So obviously San Francisco is the winner in construction, and yet we have, again, far, far more riders. And you'd think San Francisco would have the advantage that they, it's a peninsula. The Bay Bridge is very congested, so you'd have even more incentive to ride transit. But no, why? Because if you go to the East Bay, where the BART line runs north-south, you'll see that if you happen to live next to a station, that's great. But if you want to take the bus to the station, you might be waiting 45 minutes, or if you missed the last one at 7 p.m., you might not be getting home. So that is the problem. In Toronto, already by 1973, 83% of the total metro population was within 1,000 feet of transit service. 94% of those were getting service with an average frequency of under 15 minutes. That is unheard of in any other city in North America. So I'll very quickly go through, how this happened. Suburbanites, as represented by Norm Goodhead, the North York Reeve. Reeve was like a mayor for a township in the past in Ontario. He was demanding more service because Metro, it was increasingly being asked to give small, initially, subsidy to keep the TTC from going into that spiral of fare cuts and fare hikes and service cuts. So he would say, okay, we'll give you a little bit to tide you over if you have a bad year. But the suburbanites wanted either the elimination of the zone fare. They used to have to pay more to go from Scarborough or North York to downtown. And the TTC always resisted that. So the TTC finally said, okay, we're not going to cut your fare, but what we're going to do is give you a little bit of extra service. And like I said, it was an entirely political decision, but it worked. They had to do it because by that point, Metro was majority suburban. The majority of the residents lived in the suburbs. So they had to do something. So, back to this map here, the TTC was asked, what do you need to provide more service? We'll pay for it by Metro Council. And they relented. On February 12th of 62, the TTC sent a letter to all the municipalities in Metro, and they got back 79 requests for service. The TTC then recommended 40 of them. They also did an origin destination survey in the western half of Metro, basically Etobicoke, to figure out where routes would make sense in those areas. In 62, they added the first dozen routes. And for the first time, ridership ticked slightly upward. But suburbanites wanted more service. In June of 63, they pushed through a subsidy to reverse a fare hike but not to improve suburban service. The City of Toronto members of Metro Council did that. The TTC said that they would add a new bus on Shepherd Avenue, but they'll do it as the area develops. The North York Reeve said that area has been developed for the last 20 years and said they haven't a clue as to what is happening in the suburbs, the Reeve said. And so after a lot of pressure, they finally relented. They were surprised by how well that dozen routes in 62 worked. So in 63, they launched a much bigger expansion. You can see here on this map, they were boasting, this was by 64, how successful it was. And you can see in bold, I know it's not the easiest, but all the routes that were added in that expansion in 63, Finch, Shepherd, York Mills, Lawrence, Shepherd East. All of these routes were added in that 1 year Islington, and Kipling, in that 1 year period, which was a huge addition. But it really didn't cost all that much because it didn't require any new infrastructure other than a few extra buses. So you can see, Lawrence was the big winner in terms of routes. But what really blew people's minds is that overall TTC ridership continued to rise over the period by 2.5%. But the increase was entirely attributable to the new suburban riders. So ridership in the suburban, the Zone 2 it was called, outside the old city, rose by a dramatic 9.5% in the 6 months following. So 9.5% in only 6 months. But in the old downtown area, the ridership increased by only 1.1%, more than the total of which was suburban riders coming into the downtown core. So travel within the urban core actually declined. When you consider the unlinked trips, so you count a person taking one bus and then another bus separately, the increase in suburban ridership was even greater, 14%, because they were taking advantage of this new grid network they could go north on Kipling and then east on Dixon or whatever. They could now make cross suburban trips that were impossible on transit. So back to this chart, what was really striking was, and I can give you a lot more detailed figures, but I don't want to go on for too long. The TTC expected that these routes were going to cost a whole bunch of money. They didn't. In fact, and look, you can't expect this to be a normal situation, but in fact, the new services made money. They made a profit of $3.9 million overall at the TTC. So while operating expenses rose by $1.15 million to operate these new bus routes, revenues rose by $6.4 million due to increased suburban ridership, and they also raised fares in the same year to partly cover the cost of the improved service. So, the amounts massively exceeded what they had expected in their budget. So the wild success of the routes was a big part of why the TTC decided to keep adding service year after year after year, which they did. And lo and behold, demand kept rising and rising and rising. While other places around North America were saying, it's impossible to serve the suburbs. You'll never get any ridership. Look, there's no demand. The buses that we don't run are completely empty. The TTC was adding service and the riders were appearing. So what's the upshot from all this? Toronto region has high transit usage rates, even in suburbia. So you can see that, in North York, for example, 23% of people use transit across the 24-hour period, compared to 29% downtown. That's a stunning figure. 29%, that's pretty standard. Boston, San Francisco, a lot of American cities will look just like that. 23% in a suburb like North York is completely unprecedented in North America. So that is something that is really special here. And you know, you might say, oh, maybe it's population density. Well, look, North York and Etobicoke have basically the same density as LA. In fact, much lower density than Santa Ana in Orange County, which has very, very little transit service. So what does it look like in terms of routes? So Mike and I created these maps for an article I did in City Lab. And I love these maps because they show routes that run every 30 minutes until midnight, 7 days a week, which is a pretty bare minimum standard. TTC routes generally are way better than that, much more frequent than every 30 minutes. But if we held them to the TTC standard, these maps in these American cities would all be empty. But yeah, there are a few that come close, to be fair, in Columbus, but there isn't a single route in Columbus that meets that standard. In Charlotte, it's 3 routes. You know, remember, these are cities of millions of people. Denver, which is supposed to have a relatively strong transit system, and Portland as well. You can see it's really very much a skeleton network. Washington, D.C., a little bit better, but mostly just in D.C. itself. Much more limited when you get into Northern Virginia and Maryland. In Toronto, every single person in the city of Toronto is within at least a somewhat reasonable walk of a frequent bus route. And look at that. You can see 329 riders per capita, more than triple Washington, 5 times Portland. So you can see that the demand clearly also drives service, or service also drives demand. I'll go through this really quickly, but Toronto Suburban Transit, you know, you look at these areas, I've spoken to American audiences and said, what kind of service would an area like this receive? And without exception, they say maybe an hourly bus, in many cases, no service at all. There's an aerial view, an area that's probably familiar to many York students. And yet, lo and behold, the Finch West bus route is one of the busiest bus routes in North America. It's busier than the Queen streetcar downtown, and it also costs less per rider to operate. So, you know, good service with good fare recovery is possible in the suburbs. But look, if we'd only ever provided an hourly bus route on Finch, do you think those 44,000 people would be riding it? Of course not. Nobody would be riding it if they had any kind of alternative. You know, you can see this is what a bus route looks like, schedule looks like this is even in suburban New York City. You know, the last bus is at 10. Here in Memphis, the last bus is at 4:45 in the evening. You know, and again, when you look on the rapid transit side, which station looks like it would have higher ridership? This station is surrounded by a golf course, big estate houses on 1-acre lots, parking lots. This one is kind of perfect TOD. You got a nice public square, condos, office buildings, everything you could possibly hope for. Yet this one, 18,000 riders a day. This one, 27,000 riders a day. Why? Because it connects to a local bus network that brings people in from a far greater distance than could walk to the station. This station is reliant only on walk-in passengers. Is transit-oriented development a good thing? Sure. Is it going to be enough to fill a rapid transit line? Definitely not. You need to embed it in a broader network of surface transit. And yeah, you can see Toronto 16,800 riders a kilometer, Washington and San Francisco 5,000 and 2,000. So you can see much lower ridership on those very impressive, although I know they're having problems, rapid transit networks. You know, only 3 US metros had ridership growth in 2017. What sets them apart? Service improvements. So you can see Toronto actually started to get a bit worse. Why? Because the outer suburban areas, York Region, Mississauga, Durham, I know Mike's trying to fix Durham, did not follow the Toronto pattern of providing really frequent service to newly developing service areas. Brampton did something a little bit different, and they got a 288% ridership increase from 2004 to 18. They're the only ones that have really aggressively launched service improvements. And you can see this one, the timing of it is clear. On Saturday, there were no service improvements. They had an 18% ridership on this increase on this particular route. On Sunday, they went to a clock face schedule, a 54% service improvement. They had a 177% increase in ridership. So you can see it's not that they built a new development on there, because then you'd have seen similar increases on Saturday. It really is just that service improvement. You can see with the timing as well, the ridership followed the service improvement, pretty perfectly. And then when the service stayed flat, the ridership flattened out. So I wanted to go through that last bit as quickly as possible, because I know we'll be short of time, but thank you so much for having me here. It's been a real pleasure, and I welcome any questions you might have, and feel free to email me. Thanks.
Thank you very much, Jonathan. Do we have any questions for Jonathan? And also for anyone who's watching on the live stream, if you have any questions for any presenter at all, you can toss it up in chat and I will relay it to them. I think I'll start off with, so my question is so right now we're in the pandemic and we're seeing that cratering effect. What's the lesson that can be learned from perhaps history to help us restore service or return back to normal as things start shaping up again?
Well, I guess if that one's for me, I can certainly say the most important thing is to make sure that we don't start cutting service. Look, just like in the 1940s and 50s when people were buying cars, inevitably, some people are leaving the system. Now it's because of health issues or because they're not working in an office anymore, whatever it might be. The key is that if you cut service, people will disappear, and many of them permanently. So what you have to do is, when you're going through a rough patch, especially one that you know is going to be temporary, you have to make sure that you keep that service level up so that it's there when people want to come back and use it. As soon as you start cutting or raising fares to meet those temporary budget dips, you're permanently damaging your system.
Awesome insight. Thank you very much, Jonathan. Any other questions for Jonathan? Go ahead, Kieran.
This may be kind of, I guess, silly, but I was wondering, like, do you think there's like a culture of like, or like, I don't know if culture is the right word, but like in America, like there is that, huge focus on like driving, and like if you look at Toronto, like growing up here, it just seems as though you always have like a reliable bus route that you can take to get to places. But then like a similar person growing up in like an American metro area may not like experience that same level of like bus routes. So like, do you think just like simply just adding service, like bus service or whatever, or similar surface level transit, too much like service and service are really similar words. I'm kind of building myself up. Do you think that like with implementing like increased levels of service at the surface level could help change like that culture, and maybe introduce like even younger people to rely on these levels of these forms of transit, and potentially increase ridership in a long term?
I mean, I think the answer is I didn't have time to go through all the numbers I have, but the numbers clearly say that the answer is yes. Even in places like Phoenix and Houston, when you add basic local service, more people ride. Demand is not fixed. Demand is a function of service as much as it is of other things. And you're right that Toronto built that transit culture so that when you turn 16, it's not like if you grow up in the States, your parents don't buy you a car necessarily the day you turn 16, because you don't need it. You can get from your house to wherever you want to go without your friend's house or whatever, safely and reliably. I know it's far from perfect. I ride it all the time, but believe me, it is very, very different from the experience in an American city where if you live in a place that looks like the area around York University, even, you'd be lucky to see a bus every hour, if at all. And I think as well, when you look in Toronto, you just have to go across Steeles. And what you'll see is that transit ridership is much, much, much lower. And, you know, you go through a neighborhood there and you'll have 5 cars parked in a driveway. And, you know, it's not because the culture suddenly changes as soon as you cross Steeles. It's because they just don't have the transit. You know, their bus runs every 43 minutes. And in an identical neighborhood in Toronto, the bus comes every 5 or 10. So, you know, it's really just a matter of providing that basic local service if you're going to build that culture. And yes, I agree, it takes time to build up that culture.
Can I chime in for a minute?
Yeah.
If you want to look at a city, you know, America's a little different. If you want to go to one of our cousin cities, look at Melbourne, Australia. They had really poor service in their suburbs. Buses ending at 7 p.m., running every hour, hour and a half. So much so that John and I have a planning friend in Australia. When he came to visit, he couldn't believe like the bus service in suburban Toronto and how people use it. And we were like, oh, Australia has really good transit. And he's like, if you're on a train, it does, but the local buses suck, so no one uses it. And so they have a culture where if you grow up in the suburbs like he did, you get a car at 16 and the only time you're on transit is if you're going downtown on the train. And so what Melbourne did was they started a program called a safety net bus service program probably 5-6 years ago. And they upgraded these routes to run, now this is not really good service, but to run at least minimum every hour or half hour and service at least till 9 or 10 p.m. at night, 7 days a week instead of 7. And what they've seen is a huge increase in ridership, because even that little bump has made the system a little bit more attractive to some people now. So normally you'll have a elasticity of like 0.3 or something when you add service. And Melbourne is seeing like 1.5, 1.60 elasticities from these sort of minor improvements. And you're also seeing that, like John said, in the 905, where they've increased service. But Melbourne is a great one. They have a university like York on the edge of the city. And the train used to arrive and the bus to the university would depart a minute before the train arrived. And the planning professors at the university used to tell the students, well, blame your parents for the low ridership to Monash University because they chose to live in the suburbs in a house and we can't support frequent transit. Well, lo and behold, they started a bus service. For some reason, the agency finally decided, Paul Mees had told them about York University. And so they started running a bus every few minutes between the station and the university. And lo and behold, in a few years, the bus is running like every 2 minutes now, just like the old buses to York were, and they're packed. So it's interesting, you know, a few years ago, no one was taking the bus and they were saying there's no demand. And then they put it in and it's just, the demand is beyond their, like they have to put a new terminal in to fit all these buses and everything. So like John said, if you provide it, it'll take a while, but you will create that demand.
Yeah, the line I like is if you build it, they might come, but if you don't, they definitely won't. You know, nobody's going to shop at a store. You know, there's going to be zero demand for a store that doesn't exist in your town. There's going to be zero demand for a bus trip that doesn't occur. So, you know, until you provide that service, there will never be demand. And that lack of demand is the perfect excuse to always justify not providing service.
And, you know, don't take this the wrong way, but, you know, we know engineering is very heavy on numbers. And, you know, I you know, sometimes deal with engineers and they're like, oh, I don't know if you should put bus service in there. Like the demand is this. So try to think outside that box as an engineer and go, how do we create the demand with, you know, better service?
Awesome. Thank you very much, guys. I think we're going to open up the floor for questions for anyone and everyone. So does anyone have any other questions for any of our 3 presenters today?
Tim, can I go on?
Yep, go ahead.
Yeah. Hi, Audrey. Actually, my question I left from the beginning. That one is for this corridor for the LRT facilities, how we are going to introduce the signal timing. Like, are we using the transit signal parity, or in the transit signal parity whether we are going to go for early green time extension, or like um, truncated signal phase um, program, or something else?
That's a great question. I actually don't know the answer to that. I do know that the trains get priority at the crossings, but I'm not sure what method has been used. I wasn't involved in any of the signaling design. But if you're very keen, I'm sure the answer is somewhere on the Metrolink site, or I can ask colleagues and get back to you.
Sure, thank you so much. Actually, since I'm actually working on that area, that's why I was just curious that how they're doing this in this area. I'm working with the city of Toronto's the corridor, like the Queen Street or King Street corridors. That's why. Sure.
All right, it looks like it is 1:30, so some folks may have to leave. You guys can catch the archived version afterwards as well. We'll have it posted so you can hear the rest of the questions as well as our upcoming announcements, because we do have some other events coming up to check out. But first, let's keep on going with the Q&A. Any other questions? I think I've got one more question, and this one is going to be a tiny bit interesting because it relates to sort of long-term futures. So we're seeing an event of autonomous vehicles coming up, and sort of like also the rise of Uber and other quote unquote ride sharing services. What impact do you think that's going to have on transit? What measures can be made to mitigate that or incorporate those technologies to ensure that transit remains a mode of choice in the future?
I mean, I'm happy to jump in on this one. I'm not sure if the other two speakers have thoughts on this. I think, has there been a bit of, pre-pandemic, has there been a bit of an effect? Yes. The routes that tend to be hit particularly hard are routes, well, first of all, routes that are slow. And why is it that a route is slow? In part, it could just be because it's not very quick on the road or whatever, has to stop in traffic or traffic lights, whatever. But it's also if you have to make a transfer that requires, or multiple transfers that requires a lot of time. So when you look in downtown Toronto, for example, the routes in downtown Toronto have been hit pretty hard over the streetcars have had declining ridership since the 70s pretty steadily. And in part, that's because they're slow. In part, that's because their frequency has been reduced. And the problem with that is that, let's say I'm going up Spadina and I want to go to Little Italy, if the TTC's motto used to be always a car in sight, so you could always see the next car because they were so frequent. That's not true anymore. And so you might be waiting for 10 minutes for that college streetcar, which doesn't sound like a very long time, but when you're only going 2 kilometers, that's a really long wait. That's gonna maybe double your travel time when you take into account walking and all that. So those are the kinds of routes where transit really has to think about how can we provide this service a little quicker to stay competitive. Broadly speaking, and this is going to be true of autonomous vehicles or Uber or whatever, you name it. A car is still a car, and it's still going to require a certain amount of road space. And we're not making any more of it. In the 1950s and 60s, we were tearing neighborhoods down to build highways. It was common when you had a city street to tear down all the buildings on one half of that street so you could widen that street. There are lots of streets like that in Toronto. That's something that we just can't even imagine doing anymore. And so living in that world, living in that reality, we have to accept that we have very, very constrained road capacity. So the only way that we're going to be able to add to be able to move additional people is by finding alternative means, and basically that'll end up being some form of public transit. There's always the joke about Uber is, first they take you from your house to somebody else's house, but then, oh, how about we put another couple people on there, and then they say, well, okay, but how about rather than going all the way down your little local side street, we'll just pick you up at the main street. And then how are we going to know where we're going to pick you up on the main street? Well, let's put a little sign up, and maybe let's have a little shelter. And then why are we only using a 5-person car? We could fit so many more people. Why don't we have a 40-foot long vehicle? And now Uber has invented the bus. So that's kind of the problem that you always face, the kind of inevitable capacity limitations that push us in the direction of public transit in a large and growing city.
No, I absolutely agree with that. And I gave a little rant or a little talk at the Stand Up on Your Soapbox competition at the ITE Student Leadership Summit. And one of the slides that I showed, I think it's a very classic one with like the space required for like, was it like 50 people? So it shows just people on foot, people in a bus, and then all the long lines of cars. And I added another long line of cars, and just said that second line of cars, that's electric cars, that's autonomous cars. As long as it's a single occupancy vehicle, it's going to be space inefficient. And the way to get things done absolutely is mass transit. Thank you very much. Any other questions? Okay, I guess hearing none. So one last big round of applause and thank you to our great presenters for coming out today. It's much appreciated as always.
Thank you.
Thank you for having us.
And before we close out, we have a couple announcements to make. So first up, some upcoming events. We've got Civil and Geomatics Industry Night, which will be next week. That's March 29th from 6 to 10 p.m. Please do come on out and meet some industry professionals who may or may not be hiring, most likely will be hiring. And you'll be able to network with employers and see what is out there in the world of engineering. I know that Metrolinx is a gold sponsor, and they have quite a few people who are planning on attending. So it's a great idea to come out to that. Also, we'll be holding an ArcGIS Online Insights and Operations Seminar. That's going to be sometime in the afternoon on April 3rd. That is a Saturday. And finally, the end of the year is coming up, and we need to hold elections. So our IT elections and end of year social will be held on May 1st, likely in the afternoon. We need people to, we need brave volunteers to self-nominate for all of the executive positions, including treasurer. Let me just pin myself as well. Including treasurer, secretary, vice president, and president. So please do keep an eye out for that and sign up when the announcement comes. And one more thing, congratulations to Tanvir, our past president, for passing his thesis defense. Big round of applause there, congratulations.
Congratulations.
Team, sorry, it's not thesis defense, it was proposal defense.
Proposal defense, okay. Well, in that case,
congratulations.
Either way, congratulations, but there's going to be bigger ones coming down the line for you in that case.
Yeah.
And for everyone else, good luck with your final exams as the semester comes to a close.
Oh, you forgot one thing, Timothy.
What's up?
That everyone has to read Transport for Suburbia by Paul Mees. So
Absolutely recommended
that's
reading.
Homework from this session.
I don't give homework. I'm a good prof. I don't give homework. Yeah, sure. Thank you, everyone. I believe that is all I have for us today. Oh, and I just realized
very
the share
much.
screen didn't actually work. There we go. So thank you very much, everyone. Take care. Have a great rest of your day and have a great week. Thanks.
You as well.
Bye.